Hello everyone. Students, in your earlier class, that is in 11th class, you have learned about the nth roots of unity. If you might have remembered, the nth roots of unity means the power as a 1 by n of 1. And nth roots of unity are generally denoted by e raised to 2k pi iota over n. And in today's example, I have made the example set of nth roots of a unity, and I will prove that this set of all nth roots of unity will form a infinite abelian group under the multiplication. So please first you look up at this set. G is equal to e raised to 2k pi iota over n. For k is equal to 0, 1, 2, so on, n minus n. It is the set of nth roots of unity. Clearly, the value of k is varying from 0 to n minus 1, and this set contains infinite number of elements, therefore this set is infinite. So to make it a group, I will show all the properties of a group in this set. For the first property, that is for the closure property, you have to take two elements from G. The first element is A equal to e raised to 2p pi iota over n, and B is equal to e raised to 2k pi iota over n. Be careful that you have to take the elements from the given set, and the given set contains the element in the form of 2k pi iota over n. Here you can vary k, and when you vary the k, you will get the different elements in G. So I have made two elements here, A and B from G, and here P and Q are all lies between 0 and n minus 1. Now you multiply these two elements, because the operation given here is the multiplication. When you multiply these two items, you will get e raised to 2 into p plus q pi iota over n. If p plus q is n less than n, then certainly AB belongs to G. But if p plus q greater or equal to n, then you can write p plus q as n plus l, where l lies between 0 and n minus 1. Therefore, AB is equal to e raised to 2 into n plus l pi iota over n. This can be further separated out, and you can write it e raised to 2 pi iota into e raised to 2l pi iota over n. This e raised to 2 pi iota, you know that it is written as cos 2 pi iota plus iota sin 2 pi, and e raised to 2l pi iota. This is the term which I have taken from here. Therefore, now the value of cos 2 pi is 1 and the value of sin 2 pi is 0. And you will put these two values, you will get this term, e raised to 2l pi iota over n, and this is the member of G, but this is also the product of A and B. Therefore, AB belongs to G. Hence, G is closed under multiplication. So I have proved the first property of group. Now look at the second property, which is the associativeness. For that, you take three elements from G. The three elements are taken here, A, B and C. First, I have taken a bracket with A and B. So A, the value of A is e raised to 2p pi iota over n. Similarly, the value of B is C. Now you just multiply these two terms. Base are same, their powers will be added. Here 2 pi iota is common, and p plus q will remain inside the bracket. This is the third term, the value of C, 2r pi iota over n. Now again, when you multiply these two terms, you will get again 2 pi iota as a common terms, and the bracket will contain three terms, p plus q plus r over n. This is the denominator. Again, you can segment this whole part in two parts. The first part I have taken 2p pi iota over n, and another part is 2q plus r pi iota over n. Now look at this term. This is nothing but B into C. Now you can observe here that the bracket, I have taken the bracket somewhere here, but when I simplified it, this bracket shifted from AB to BC. This proves that G is associative under multiplication. Now again, for abelian, because I have to prove it as a abelian group, so you have to show that A into B is equal to B into A. A into B is e raised to 2 into P plus Q pi iota over n. But P and Q can be interchanged because there is a summation between P and Q. So when you interchange P and Q, you will get e raised to 2 Q pi iota over n, e raised to 2 P pi iota over n. But this is nothing but BA. Hence AB is equal to BA. Therefore G is abelian. Next. Now I will search for the identity element and inverse element in the group. Clearly, 1 is the identity of G and inverse of 1 is also 1. Let e raised to 2m pi iota over n is not 1 be any element of G. Then for 0 less than m less than n we have, अब देखो यहाँ पर क्या किया गया है, I have taken minus sign, added minus n on each side, 0 minus n, m minus n, n minus n, 0. Now I have multiplied with my negative sign on all the three terms. When you multiply the terms with negative sign, then these inequality get reversed. Here it is less than, when I multiply with negative, this will get greater than. Hence I get here n minus n lies between 0 and n. Implies e raised to 2 m n minus m pi iota over n belongs to G. When you multiply this whole term, actually I am searching for an element from a G. So this is also an element in a G. When I multiply this element with another element, that is 2m pi iota over n, I will get e raised to 2 pi iota. Other will get cancelled out. And e raised to 2 pi iota is nothing but cos 2 pi iota plus iota sin 2 pi. And cos 2 pi is 1 and sin 2 pi is 0. This is nothing but 1. Thus for every element e raised to 2 m pi iota over n, there exists e raised to 2 n minus m pi iota over n belongs to G, such that product of these two terms is 1. Hence every element of G is invertible. Therefore G is abelian group, because I have proved all the properties in a group for the nth roots of a unity. Thank you.